this section, we are going to discuss how to write an ALP, that is assembly language program, for a particular problem. For that, let's consider our first program, that is write an ALP to create an array of 8-bit numbers with following pattern in memory location starting from 8101 onwards. The number of elements in the array is stored in location 8100H. This is the pattern of numbers 77, 78, 79, 80, 81, 82 and so on. So likewise we need to create an array. So based on these problems, the number of elements in the array is stored in location 8100. So 8100 contains number of elements in the array. Say in array we can have 5 elements. So we need to create a programs to create an array like this, so that after execution of that programs, 8101 contains the data 77, 8102 contains data 78, 8103 contains 79, 8104 contains 80 and 8105 contains 81. So in this manner we need to create an array after execution of that program. So in this problem we need to create a pattern like this. So important points to be noted here is that number of elements in the array is stored in location 8100H. The first elements in the array is given as 77. The second elements in the array should be 78. How to obtain 78 from 77? Obviously we can add 1 with 77 so as to obtain 78. That is 77 plus 1 gives 78. So in microprocessor, how to obtain this one? What are the available instructions to do above operations? In question it is mentioned that after execution of these programs, the number 77 should load into 8101. For that one, we can declare the memory pointer like this, so that the content of memory location pointed by HL pair, that is M, denotes 77. So by manually we can enter the data 77 into 8101. So after execution of this instruction, M denotes 77, that is content of memory location pointed by HL pair, that is M is equal to 77 under this case. Then if we are incrementing, what happens? The content of memory location pointed by HL pair will get incremented by 1. So after execution of this instruction, content of 8101 becomes 78. Again if we are incrementing, the content of memory location pointed by HL pair become 79. Again if we are incrementing, it becomes 7a. Again if we are incrementing, it becomes 7b and so on. But we need a pattern like this. So this is our wrong route. So we need to think about another method. So same way we can load 77 into this location 8101. Then we can move that 77 into accumulator by means of this instruction, that is move a comma m. Then we can add 01 immediately with this number. So by means of this instruction, content of accumulator is get added with this immediate data and the result is available in accumulator. So after execution of this instruction, the content of accumulator becomes 78. Now if we are adding this result with again 01, we can obtain the result as 79. Again if we are adding with 01, so operation is 79 plus 01. We can obtain 7a. Again we are going into another route. We need this pattern. So this is also wrong route. So here it is to be noted that after adding 1 with 79, hexa data is becoming 7a. But we need 80. There comes the importance of DAA instruction. that is decimal adjust accumulator. So immediately after, if we are providing DAA instruction, what will happen? 79 plus 01, the result becomes 7A. After this instruction, if we are providing DAA, this 7A will convert into 80. That is similar to earlier case. In 8101, we can load 77. Then we can take that data into accumulator. Now we can add 1 with this 77, so that content of accumulator become 78. Now after this one, if we are providing DAA, nothing will happen. The same result we can obtain. Why? Because LSB nibble of content of accumulator is less than 9 and MSB nibble of content of accumulator is less than 9. After DAA instruction also, the content of accumulator retains 78. After this, again if we are adding with 01 by means of this instruction, content of accumulator becomes 79. After DA instruction, nothing will change. Again we can obtain the same results in accumulator. After that, again if we are adding with 01, content of accumulator becomes 7A. After DAA instruction, content of accumulator is changed to 80. So this is the importance of DAA instruction. So this is the right way which we need to follow in order to create this type of patterns. So in order to make the programs more general, it is better to obtain the result automatically after execution of this program. So unlike this method, it is convenient or it is better to load the data immediately into the specified location by means of suitable instruction. For that, we can use this method. First of all, let's declare the memory location. Then into that location, we can load this data, first data immediately. So this method we can utilize in order to make the programs more general. Now let's see this step-by-step procedure in order to create this pattern. First of all, as mentioned in question, the number of elements in the array is stored in location 8100. So in order to ensure all numbers, that is all elements in the array is taken into account, we need to use that count. Say we are going to save that count into C register by means of this instruction move C, M. So count, that is number of elements in the array, is now available in C register. Say in our case we can have 5 numbers in the array starting from 77, 78, 79 and so on. Now we need to point next location. So in next location we need to save the first element 77. So how to obtain 8101? We can use this instruction or by means of INXH. Once we completed memory initialization by means of this instruction, next location can be obtained by means of INXH. So INXH is equivalent to LXIH 8101. Now the memory pointer is pointing 8101. So into 8101 we need to save the first number. How to save that one? Just like this one, we need to move the data 77 immediately into this location. Now first data is reached into the first location 8101. So after execution of this instruction, 8101 contains 77, the data, that is the first data. Then in next location we need to save 78. How to obtain 78 from 77? For that one we need to use this method. So the first number, that is 77, should reach into accumulator in order to do this process, so that we can obtain 78 after addition with 01. So this data which is now available in that location 8101, that we need to move into accumulator by means of this instruction. Now content of 8101 is equal to 77. and which is the data available in accumulator. So now we can add 0, 1. After adding 0, 1 with the 77, the content of accumulator becomes 78. Now we can use DAA, nothing will change. The content of accumulator becomes still 78. This result we need to save into location 8102. How to save this result into 8102? For that one, again we need to increment the memory pointer so that it will point the location 8102. Now the memory pointer will point this location 8102. So into that location we can save this result. Where this result is available? The result is available in accumulator. How to move the accumulator result into this memory location? For that one we can use move em, a. So after execution of this instruction, 8102 contains 78. Now we need to reduce this count by 1. So decrement C, and we need to repeat till the count becomes 0. Now the count becomes 4. Again we can add 0, 1 with content of accumulator. What is the content of accumulator now? It is 78. So 78 plus 1 gives 79. So after execution of this instruction, the content of accumulator becomes 79. Again we need to convert that into BCD by means of this instruction. After DA instruction, the content of accumulator still retain as 79 itself. Now we need to save this 79 into location 8103. So for that one we need to increment the memory pointer by means of INXH instruction. So after execution of this instruction, HL pair will point next memory location, that is 8103. So into this location we need to move 79. For that one we can use move M, A. Next again we need to decrement the count. So after execution of this instruction, C become 3. Again we need to add 0, 1 with the content of accumulator. Now the content of accumulator is 79. 79 plus 1, the result becomes 7A. After this one, if we are providing DAA instruction, after execution of this instruction, the result becomes 80. That is BCD number. Now we need to save this 80 into location 8104. For that one we need to increment the memory pointer so that that memory pointer will point next location 8104. Into that location we need to save this result 80. For that one we can use the same instruction move M, A. So after completing the execution of this instruction, content of accumulator, that is 80, will loaded into 8104 location. Next again we need to decrement the count. The C content become 2, which is not 0. We need to repeat till C content become 0. As C content is not 0, we need to add 0, 1 again with the content of accumulator. So previous content of accumulator is 80. If we are adding 0, 1 with 80, we can obtain 81. Again DAA instruction is used. There is no change, 81 itself. Now we need to save this result into next location. Next location is obtained by means of INXH. Now after execution of this instruction, HL pair will point next memory location, that is 8105. Into this location we need to save 81. How to save that one? Again we can use move M, A. So after execution of this instruction, 81 will move into this location. Now again we can decrement count by 1. So after decrementing the count by 1, now the content of C become 1. As C is equal to 1 is not equal to 0, again this process will repeat. That is ADI 01. Now the content of accumulator is 81. With that 01 is get added. So after execution of this instruction, content of accumulator become 82. Again in order to convert this into BCD, we can use DAA. So after DAA instruction, still the result is same 82. In order to save this result, we need to point next location In order to point next location, we can use INXH. After execution of this instruction, the memory pointer will point location 8106. Into that location, we need to save this result by means of this instruction. And again, we can decrement C. So after decrement C, now we can obtain C content as 0. As C becomes 0, we can stop the process. Here, we reduced the content of C by 1 5 times so that finally the content of C becomes 0. So during this time we can stop our process, that is program. In this program there is a small mistakes that you need to point out as comment. Before execution of this instruction, the content of memory location 8100 is something. Say it is represented by don't care. We don't know about that one. So this is our general program in order to do about task. In location 8100 contains the number of elements in the array. So that we are moving into C register by means of this instruction. Next, in order to obtain the next location, from which location onwards we need to save the data. For that one, we need to use INXH. So into that location, we can save immediately the first data 77. The same data we need to move into accumulator in order to do this addition process. So after ADI 01, what will happen? We can obtain 78 in accumulator. In order to do BCD conversion, we can use DAA. In first case, as mentioned earlier, 78 itself we can obtain. So this result we need to save in next location. For that one we can use INXH. That result is available in accumulator that we need to move into this location, which is pointed by HL register pair. Then we can reduce the count. We need to repeat the process, that is adding 0, 1 and converting into BCD and saving the result into that memory location. That process we need to repeat until C becomes 0. Jump no 0 repeat means if above result the content of C is not become 0, we need to repeat one process. So repeat is the location corresponding to this instruction. For simplicity we can use repeat. Actually this is a memory location, 16-bit memory location corresponding to this instruction. Whenever this instruction is executed, if the content of C register is not 0, the program control will branch into this location. That is, it will start to execute ADI 01. Again we can obtain 79. After DAA 79, that result will save into next location and so on. Finally, the last time C content becomes 0, this won't execute it, it will directly execute halt instruction, that is stop. So finally, after execution of this program, we can obtain the result like this.